question. This is the technique you should apply. I'm teaching you a technique, a skill. Question always change, but technique doesn't change. When you do this kind of question, always do in two things. Number one, information deduction. From the information, let's say this is the information. Molecular formula C9H10. Information number one. What can you get under the deduction? Okay? Deduction, there are 4 things we mark for in exam. Actually, there are 6, 4 or 5 or 6. But 4 of them are the things that you confirm must write down whenever possible. What are the 4 things? 1. The type of reaction. That means it's a free radical subla, section, oxidation, acidic hydrolysis, alkaline hydrolysis, acidification, nucleophilic, blah 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 blah. Number 2. From the information, are you able to tell the functional group? Or is it a carboxylic acid group lah? Is it a double bond lah, alkene lah? Is it a arene lah, blah 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 blah? Or is it a halogenal alkane? Or is it an alcohol, blah 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 blah? Number 3. All this will earn you marks. Okay, you can write 1 page of chemistry thing but you don't get any mark one. Just like your study econ, right?
No.
You take what? Page 1 is what? History. Most of you econ got some history.
Literature.
And job. So just like econs, history, job. You can write a lot of things and what?
Literature.
Oh, literature, okay. I like literature a lot as well. Okay, you can write a lot of things, but you don't get mark. Why? Because they are irrelevant, they are not what the marker want. So same thing, you can write a lot of things, but none of it belongs to what the marker want. So no use. I only want what the exam wants. Type of reaction, functional group. Number 3, special arrangement. You have not learned this thing, special arrangement. But you are going to learn it soon in alcohol. Example, in isoform test. So this one you just take note, but you have not learned this. Isoform test. Okay? Example in isoform test. This one you learn in alcohol and carbonyl. Number 4. What else? Type, functional group, special arrangement. What else? One more. I will not talk about it. You have not learned yet. You have not learned, so I will not talk about it. That's why I mark a star down there. One more is the... What else? Cannot remember at this moment. Okay. I know you will only write this equation when asked for. This one you only write when you ask for. Okay? When asked for. You will not write equation unless they ask for. What else? Okay, these are the things that I will tell you at the moment. I don't want to waste time thinking about it. I will add on to this later on. Anyway, don't worry. When I go through a subsequent question, I'm going to go through this one more time. But these are things to look for. So, for example, C9H10. What does this information tell you? This information tells you about the... somewhere here. Oh, okay. So if this is number... You change the numbering. So this one is something you write the structure. You draw the structure. When you have C9H10, when the carbon to hydrogen ratio is about 1 to 1, it means there is a benzene ring. It is aromatic. The clue is actually written down here. Okay? This is one of the information, one of your deduction. By right, you are supposed to write this as a deduction on your own. You understand what I mean? Okay, let's see. If you have this formula, you use up benzene ring. Can you tell me how many carbon you left? Left 3 carbon, right? How many hydrogen you left? About 4, right? 3 carbon, you can put like that. 1, 2, 3. Each one get 1, right? But if you put like this, you have not enough hydrogen to complete the diagram. So, it could then be what? It could then be what? Like this. But if like this, you also not enough hydrogen. So, there is possibility of double bond. But how do we confirm that? The subsequent answer will tell us. Let's check. The subsequent question. So, you know it's something like that already. in your mind. Okay? Look, the second statement says what? J react co-KMnO4. Co-KMnO4, so far where you learn? Alkene, right? So that means there is a double bond. So you confirm there is a double bond. Like this. What type of reaction has occurred down here? Yes, so you can write down mild oxidation as the mild oxidation. So I'll give you half a mark again. Here I never mark for the marks because you have not reached the stage yet, but I'm training you. I'm giving you advanced training. Okay, mild oxidation. So you get this. So you know there will be 2 OH. Do you realize there's a change in the number of oxygen and hydrogen? So that means the 2 OH go inside. 2O, 2H. Just nice. 2 OH. So you confirm. When J is refluxed with KMnO4 acidified, you form this. This one. You form this one. What does it tell you? That means 2 carbon here, 1 carbon here. Correct? So you settle the 3 carbon already. So you know it's like this. When you settle this already, right, put in the H. Do you realize it fit into the original molecular formula just nice? 1. Does it fit in just nice? Yes, right. So this you get your answer. It's the same. Then you check. Do you have side chain oxidation for both of them to result in this? This reaction with the KL4, does it result in side chain oxidation? Yes, so that's the type again. Does it give you carbon dioxide for both of them? Give you what PPT? Yes, so you confirm the structure. So you draw this as your answer already. Once you get this as the structure, can you do the subsequent? Can J react chlorine in the dark? In the dark, is there free radical? No. That means the chlorine add to where? Here and here. Can the chlorine go to here? No, no free radical. Can it go to here? No, no free radical. Can it go to here? No, because you don't have AlCl, AlCl3. You don't have a halogen carrier. So it will not go to here, so it only goes to here. You understand? That's it. So you confirm your L, which is your answer. No, which show optical activity. Is that a chiral center? If you look carefully in your... Yes, there is a chiral center down here. So optical activity. Done. Okay? Then subsequently, you can write down, of course, this is what type of reaction? Electrophilic addition. Then J react chlorine gas under UV light. This is free radical sub. Free radical sub. Give you M, but no optical activity. So where must the chlorine go to? Where must the chlorine go to? The CH3O, which is down here. No, this one no chiral center one, because this carbon got 2 hydrogen. So no chiral center. Okay, you also got this answer. Then after that, what happened? Any more question? No. Then after that, you can draw this on your own, the 2OH, which is okay. Just like that. This is a simplified answer. Of course, you can write down the type of reaction, everything on your own. Queries. Any queries? That's why I said, come for my lesson, you must prepare. If you don't prepare, you just waste your 1 hour 50 minutes. 1 hour 40 minutes. Then you go home, got to spend another 1 hour 40 minutes trying, or longer, trying to digest the whole tutorial. If not, you never catch up. You do it now properly, you go home, you got less things to do. And you got more time on your Facebook and other stuff. Or, you can have more time to study and to benchmark yourself with other people. Question? I give you 3 minutes to digest before I go to question 10. Which I have 10 minutes to go through. Or slightly less. Because I've got something else to tell you. The next thing I will be going through will be, I'm going back to this question. Question is 5. I'm going back to question 5. How you should be able to digest. Your question 9, okay already? Any queries? Yes?
For L, right?
For L, okay, let me go to L. What is it about L?
What the CL added to the
Why L you cannot have the thing added to the benzene? Because you never use. If you want some, we don't say added to the benzene, we say substitute at the benzene. Why it never substitute? L never substitute at the benzene ring. Because if you want the chlorine to go to the benzene ring, you need a halogen carrier, AlCl3. You read your lecture note, it needs an AlCl3 or FeCl3 or iron, Fe, to act as a carrier. Okay, I show you in your lecture note, it's down here. You take a look. For bromine, you need this. So for chlorine, it's the same. If you look carefully, you need all these conditions. You need a halogen carrier. Okay? So if it's chlorine, what will the equation look like? How will the equation look like? If it's chlorine, the equation will look like this. So Cl2 plus, let's say AlCl3 will give you Cl plus AlCl 4 minus. Yes. Very good. That's all. Okay? Okay. He brought me to my question. For this particular reaction, right, if you want chlorine and bromine to be substitute, replace. Replace is the same as substitute. Can you tell me what is the condition normally for benzene ring, right? If it's methyl benzene, how would you think it would differ? Would it be different? No, it will still as room temperature. Because like this room temperature can occur. If I have methyl benzene, which is ring activating, it will occur even at a lower temperature, but I just put room temperature. That will be the correct answer. But if I have a ring deactivating, what will this be? You need to heat. Not 55, but rather you need to heat. That's why your answer down in this question 5, if you notice carefully, yes. So this condition now becomes important. That's why you need to integrate every single thing. As you learn, move on, right, you may learn hate chemistry or organic chem, I should say. But remember, you cannot hate chemistry. I don't need you to love it, but you cannot hate it. Because if you hate it, you will not do well. You need not love it to do well, but at least you must remain neutral and be open to learning and memorizing. Okay? Question? Take note of all these things. Any other queries? If no, then let me give you a question which is not in the tutorial. Let me ask you something. Okay, here. Back to this slide, this one here. Do you realize that if I have a benzene ring at a Br, I must have this equation, correct? To generate the electrophile and then everything repeat the same, correct? If I want to have Cl to be at the, if I want Cl at the benzene ring, I must have the one that I've written, right? To generate electrophile, right? Now, the question comes. If I want CH3 to be at the benzene ring, can you suggest a reagent and the condition for it?